Next, we have quadratic equations with complex solutions. So if we were to solve these algebraically, what that really would mean would be to try and factor this and then solve. So for the first one, y equals 2x squared plus 3x minus 5. If we were to try to solve this quadratic equation, I personally look at this and I'm like, all right, the square root method doesn't look like it's going to work. Why don't I try and factor it? So we would have to look at 2 times -5, so it multiplies to be -10, and adds to be 3, so that would be +5 and -2. I would break this up into 2x squared plus 5x minus 2x minus 5. Factor by grouping. I can take an x out. I'm left with 2x plus 5. I would take a -1 out. I'm left with 2x plus 5. And I should start here by saying that I actually need to change this y into a 0. So it's like equal to 0. So when you get an equation in y equals form, just replace that y with a 0, because our whole idea here is to figure out where the equation, which is y equals 2x squared plus 3x minus 5, crosses the x-axis, which that means when it equals 0. Because the x-axis, y equals 0. So I forgot to say that in the beginning, but when I'm complete the rest of this, I would get x minus 1 times 2x plus 5 equals 0. And then I would solve this out. So x minus 1 equals 0, and 2x plus 5 equals 0. I get 2 answers. It crosses at 1, and it's going to cross at -5/2. So the first equation will cross at those 2 locations. You can always check with Desmos or your calculator. The second one, if I go to factor this, what multiplies 2 times 2 to be 4 and add to be 4, well, that would be 2 and 2. So I'm going to factor 2x squared plus 4x plus 2, but before I do that, I should replace y with 0. And this would be broken up into 2x plus 2x plus 2. And I'm going pretty quickly through this because we already know how to do this. X plus 1 and x plus 1. So we get 2x plus 2 times x plus 1. Now I could factor this further if I really wanted to. I could have taken a factor of 2 out from the very start. Either way, 2x plus 2, if I factor that out, it would be 2 times x plus 1 times another x plus 1. 2x plus 2 equals 0, and x plus 1 equals 0 will give me the same answer. Minus 2 minus 2, 2x equals -2. I get -1 for that answer, and I get -1 for this answer as well. So this quadratic actually only crosses the x-axis at 1 location. So the first one crosses at 2 locations. So at -5/2, which is -2.5, it's going to cross, and at +1, it's going to cross. It's going to look something like this, let's say. But this one actually only crosses at 1 location, so it actually doesn't go below the x-axis. It just touches it. But then once we get to the next 2, this is where the complex solutions come into play. Quadratic equations can cross the x-axis in 2 places. They can touch the x-axis in 1 place, or they don't actually cross at all. And when we go to solve these types, it's not going to work out. Like if we tried to take this equation and factor it, replace 0 in for y, and try and factor x squared plus 4. It looks kind of like a difference of squares, but it's not, because it's not a difference. We can't figure out what multiplies to be 4, adds to be 0, because that's not going to work with 2 positives or 2 negatives, so it's not factorable. So let me then try to see if I can use the square root method by isolating the x squared. When I move the -4, or when I move the 4 over, it turns into -4. So I get -4 equals x squared, which in the real world system, that would never work. If I go to try to solve this using the square root method, I would take the square root of both sides, and in the real world system, this does not actually work. But in the imaginary system, the square root of -4, we know, is 2i. Now, when we do take the square root, we have to realize that we do get 2 answers. So this would be plus or minus the square root of -4, which would be plus or minus 2i. So this actually crosses in two locations at 2i and -2i, which is incredibly difficult to even imagine, because if we were to pull up Desmos, if we pull up Desmos and I type in that equation, y equals x squared plus 4, it's pretty clear that it doesn't cross the x-axis at all. But in this case, we do have to realize that in the complex world, in the imaginary world, we can still find solutions. So it would be 2i and -2i. And then for the next one, this looks like a perfect setup for the square root method. So I would subtract 2 from both sides, making this 0, of course, at first. We would get -2 equals the quantity x plus 7 squared, and then we undo that by square rooting. Now, when we do square root both sides, we have to realize the other side here is going to be plus or minus. So it's going to be plus or minus the square root of 2i. And then what we would do to solve this is subtract 7. So we would get -7 plus or minus the square root of 2i as our two answers for where it would cross the x-axis, even though it actually doesn't. So then the next thing, what it wants us to do is use the graphing calculator to check the solutions. I kind of already went over that and did that as we went through the problems. But the two that have real solutions would be, of course, A and C. And the two that have complex solutions, that would be B and D. So when you have actual real solutions, you have x-intercepts. So A and C have actual x-intercepts. But the ones that did not, B and D, when you don't have x-intercepts, that's when you have those complex solutions. And then what it wants us to do is make a conjecture, compare the x-intercepts of the quadratic equations and the types of solutions. Basically, if they have x-intercepts, then that means it's going to be a real answer. It crosses the x-axis. But if they don't have x-intercepts, you're going to get a complex answer in the imaginary world. Okay, so if we flip this over to the other side, we've got just some more practice problems with complex solutions. So for the first one, x squared plus 8 equals 0, I would subtract 8 from both sides. Get x squared equals -8. Not going to be a real answer here. But when I do this, I'm going to get x equals plus or minus. And then we would want to rewrite this as 4 times 2 times -1. And the square root of 4 is 2. The square root of 2 will stay the square root of 2. And the square root of -1 is I. So this would be the two locations of this imaginary quadratic where it crosses the x-axis. And then the second one, again, square root method, way to go here. -32 minus 32. We would get 2 times the quantity, 3x minus 5 squared equals -32. And then let's divide both sides by 2. And let's undo the square by square rooting. So we get 3x minus 5 equals plus or minus the square root of -16 is just going to be 4i. Now our whole goal here is to solve for x. So let's add 5 to both sides. We get 3x equals, I'm going to put the 5 first because the real number comes first in a complex solution. 5 plus or minus 4i. And then I divide everything by 3. So we would get, my solutions are 5/3 plus or minus 4/3 I. And then for C, we're going to subtract 3. Let's undo the square by square rooting. We get x minus 4 equals plus or minus the square root of 3i. And let's add 4, and we get the solutions are 4 plus or minus the square root of 3i. Okay, so for the checkpoint questions, let's try numbers 1 and 2. You can pause the video if you'd like, and then press play when you're ready to check your answers.